Okay, the three principles of experimental design: we're going to control the effects of lurking variables on our response variable. We're going to randomize both by using a random sample and randomly assigning subjects to treatment groups. And then replicate. We're going to make sure that we use enough subjects in each group so we reduce the variation in our results. Okay, there will be an exam question that on the written part of the test that'll ask you to identify these three principles, and then you'll be given an experiment and asked to analyze whether they were part of the experiment or not. You will have a quiz question like that as well, so you'll get a chance to practice that with your group. So our first principle is control. We want to control the variation by making our groups similar. We also want to control our factor by assigning different levels to it, and we want to make sure that those levels are appropriate. So if I was testing the effect of exercise on heart health, I wouldn't have one group exercise for 30 minutes and another group exercise for 31 minutes. Those two are very close together. I'd want to have maybe one group for 30 minutes and another group for an hour. Okay, so we just want to be very thoughtful in the levels that we choose for our treatments. Okay, and then also we use a placebo with our control group so that we know that the effect is coming from our treatment and not from something else like perhaps mind over matter or something like that. And we're going to talk more about placebos and control groups and blinding in another video. So that'll come up again. Our second principle is randomization. So that allows us to equalize the effects of variables that either we can't control for or ones that we're not even aware of. So it doesn't eliminate their effect, but what it does is it spreads it out across the treatment groups. And so we can see past those variables and see if the treatment is actually helping our subjects or participants. Okay, so it reduces the bias. It won't eliminate it completely, but it does minimize it, it does reduce it. And another reason that we're really interested in randomization is that the power of statistics comes from probability and random chance. So if we haven't done a random sample, haven't done random assignment to treatment groups, we're not able to access the full power of statistics in order to draw conclusions like cause and effect from our experiment. So a common saying in statistics is control what you can and then randomize the rest. And then that leads to our third principle. So our third principle of experimental design is replication. And we'll look at two aspects of that. The first is that you want to have a large enough sample size so that when you assign subjects or participants into treatment groups, that each treatment group has a good number of people in it. If your treatment ends up with only 1 or 2 people in each group, then you don't know if it's the treatment that's actually affecting them or if there's just some other fluke or random chance that's going on that, that made the change that you're observing. So a good healthy number of subjects is important. And then another aspect of this is that you can't always get a random sample. We would love to always have a random sample, but there are situations where that's not really feasible. So for example, a drug trial relies on volunteers. And so maybe a doctor in Denver is trying out a new cancer medication. And so he or she has gotten volunteers and they proceed with this drug trial. And another doctor in St. Louis does the same thing. And maybe in Tampa and Virginia Beach and New York City and Phoenix and LA and Seattle, right? So all across the geographical area. So hopefully we're getting kind of a really wide cross-section of people. And what we're looking for is for these results to be fairly consistent across all of the repeated experiments. If they are fairly consistent, then we can apply our results to our larger population. If they're not consistent, if the results are kind of all over the place, then we want to take a look at the design of the experiment, see if there's something going on, some variable that we didn't think of, or some design element that we need to control for. Because with that much variation in the results, we can't apply our results to our larger population. Okay, so our 3 principles of experimental design are control, randomize, and replicate.